Moisture determination is one of the proximate analyses that is carried out in any given food. Food contains three types of water, that is type 1, type 2, and type 3. The importance of knowing the moisture content in your food is that you can be able to establish its microbial stability, hence the shelf life. You can also be able to determine its processability. For this demonstration, our sample of choice was carrots, which we outsourced from
Sample preparation involved washing, cutting, and dicing the carrots, then drying them in an air oven for 24 hours. The carrots were grounded using a grinder and collected in a polythene bag for storage away from moisture.
One of the methods of moisture determination is using the oven, and in ovens we have two types. We have the air oven and the vacuum oven. In air oven, 5 grams of the sample was weighed and placed in the air oven, which is set at 60 degrees Celsius for 24 hours. And in vacuum oven, 5 grams of the sample was taken too, and it was placed in the vacuum oven, which is set at about 25
Another method of determining moisture in food is distillation method, and this method involves direct measurement of volume of water which is removed from food by evaporation. This method involves the co-distillation of moisture together with high boiling and an immiscible organic solvent. The method is as follows. You measure 25 grams of the food sample. Then you transfer the food sample into 500 ml flask. You add the toluene, which is the organic solvent, into the food sample, just completely cover the food sample. Then you add some toluene through the top part of the condenser. Then you begin boiling slowly, and for some time you allow the distillation to take place at the rate of 2 drops per second. Then you increase the rate of distillation to about 4 drops per second. And afterwards, you add some toluene through the top part of the condenser to collect the water to the receiving tube, to ensure that all the water is collected to the receiving tube. You continue for about 15 minutes, and if you find that the volume has increased by 0.1 ml here, then you can repeat the process to ensure that all the water from the food sample is collected. Then finally, you take the water collected the mixture collected, because this is a mixture of toluene, which is the organic solvent, together with the water. But the water will be found in the lower layer because it is denser than the solvent which was used. So you take the mixture, you take it and cool it at room temperature, and finally you read the volume, and therefore you will be able to get the volume of water which is collected from that sample. But then we have the advantages of using the distillation method as one of the methods of determining the moisture content of food. One of them is that this method is used for those food which have low moisture content. Then two, the method also is simple. The apparatus, they can simply be set.
I'll take you through the Karl-Fischer method for determination of moisture content in foods. The Karl-Fischer method is used to determine the moisture content for foods which have a low moisture content, such as coffee, dried foods, confectionery foods. Now, this method is quite simple, and it involves the equation right here, where in presence of water, sulfur 4 oxide reduces iodine to hydrogen iodide. Now, in the reaction setup, what we have is that the sample is put in a titrating flask, and we have the burette of the injection syringe where Karl-Fischer reagent runs through. Then, as you add the Karl-Fischer reagent, you're going to have color change. You're going to observe color change in the solution right here, from reddish brown color to colorless. Now, you have to mark the endpoint of that reaction, where you no longer observe the colorless color, but you will have the red-brown color, which is the color for iodine. Now, at that point then, you can mark the endpoint of that reaction. However, this method is complicated because it's subjective to color observation. Hence, the method has been improved to use electrical methods where the electrodes and electronic relay system can directly refer to the endpoint.
In our calculations and in our experiment, we had 3 methods that were used, and the first method was determining the moisture by air oven, and then we used vacuum oven, and finally we were able to use distillation method. And in air oven, we had the moisture content of our material or our sample was 88.76 on wet weight basis, where in dry weight basis we had 11.4. In the case of the second method, which was used, that is vacuum oven, we were able to get 88.79 on wet weight basis, whereas we had 11.21 on dry weight basis for the second experiment. And finally, the last experiment that we were able to do was by distillation method, whereby we were able to get 90.03% of moisture on wet weight basis, whereas we had dry weight basis, we obtained 9.97. For the 3 methods used, we see that distillation method is the best method because it was able to extract most of the moisture content of that water, followed by we had vacuum oven had was the next one, which had 88.79 on wet weight basis, whereas air oven gave the rest, that is 88.76. So for the 3 methods, distillation method is the best, then followed by vacuum, and then we had air. In this case, we have other methods which can be used, that is, for example, Karl-Fischer method, but we were not able to go and extract moisture through this method due to an availability of some equipment that are necessary for the same process. So in this case, I advocate that this method is the best which can be used for the same purpose, for us to be able to obtain the moisture content of the material.